Okay, in this video, I wanted to discuss the difference between a compression check and a leak down test. And also I'm going to be performing one on my 1990 Toyota pickup, which has a 22RE in it. And if you've been subscribed to the channel for any length of time, you know that I recently rebuilt the engine, put new pistons, and did a valve job, ceramic coated the chamber as well as the valves, the intake or the exhaust runners, and above and beyond just the recent compression check I did to see if we can get some insight into how the truck is doing. So first I wanted to talk about the differences between a compression check and a leak down test. Just for anyone who is curious or has never done a leak down test, I think most of us, particularly people subscribe to the channel, and if you're not subscribed, please do consider subscribing as it helps everybody out. I think most people subscribe to my channel by now have done a compression test on their vehicle. And just to recap what a compression check is, that's where as you cycle the engine, the piston goes up and down, and it compresses its intake charge into this chamber here. And if we connect a compression gauge here through the spark plug spark plug hole here, then whatever pressure is generated inside the cylinder head chamber will be shown on the gauge. And of course, with a 22RE, we hope it's around 170 psi. Generally, you cycle the engine 10 seconds or so, and because there's a little check valve right here, the pressure being generated inside the motor is captured in this gauge, and eventually the needle won't tick any higher, and we see the compression readings. And just to recap real quick, we want all the readings across cylinders number 1 through 4 to not deviate much more than about 5%, ideally, and that we don't want any readings below, I believe it's 140 psi roughly. So if you have 170, 170, 120, and 170, that's indicative of a serious problem and some sort of failure internally with either the piston rings, which are sealing, or the valves in the cylinder head itself, or worse, the head gasket between the block and the cylinder head. Now, that can give us some good insight into the health of our motor for sure. However, it doesn't tell you the whole story. You can think of it like a snapshot. What we want is to see more of a movie of what's going on, and that's where we start talking about leak down tests. So it's very similar. It's the cousin to a compression check, but it varies in a couple different ways. And most importantly, you have to have slightly more sophisticated equipment, and that's generally called a leak down tester. Now you can find these on Amazon and all over the place. I'll insert a picture of the one that I own. It's a vintage leak down tester made by Total Seal, the same company whose rings I use in my motors. And as you can see, it has 2 gauges on it, as I've illustrated in this drawing, and both those gauges are direct read gauges. They're German-made gauges which read 100 psi. Now, because my leak down tester is older, it's slightly higher quality than what you typically find today. If you look on Amazon, for example, you'll see gauges that the second gauge reads in percentages. And while that's totally okay, I personally prefer to have 2 actual PSI readings. So I think the best way to begin to understand how leak down testing works is to understand the equipment. So I've drawn it kind of here, and you can see that it's just like a compression tester. It's connected to the motor through the spark plug hole illustrated here, and so it's capable of reading whatever pressure is inside the engine. The difference is where with a compression test, we cycle the engine for 10 seconds to build pressure up. In the leak down test, we do not do that. So the piston remains static generally. What we do is we take the piston and we rotate it to top dead center on whatever cylinder we're testing, say it's number 1. And you want it at top dead center of the compression stroke so that the valves in the engine are both closed. So what we're trying to do is pump air into the chamber when it's at its closed position just prior to or at when the spark would occur, and we want to simulate some pressure in there and then see how much of that pressure leaks out in real time. So we need to be able to. We need an air source, first of all, and that's going to be an air compressor typically. So you have your air compressor. And usually you need somewhere between 80 and 100 psi of air supply. And what you do is you run that air into the leak down tester. And the leak down tester, as you can see here, has a manifold and a regulator. It has its own regulator on it. And I should interject here that when you first connect your leak down tester to your air source, it's of paramount importance that this regulator right here is dialed all the way open, because these gauges here are generally going to be using what's known as a bourdon tube inside them, and they are very susceptible to damage if they're overpressurized. So what you do not want to do is connect your brand new leak down tester to 120 psi of air and have this regulator right here dialed all the way in. So that's the first thing to be aware of. Once you connect the air supply, then you can carefully dial the regulator up and introduce 100, or it doesn't have to be 100, it could be 50, but some known amount of air into the gauge. Now, when I do the compression check on my motor here in a minute, I like to use 100 psi exactly. And the reason for that is it makes mathematical calculations very easy. Now, if you have a gauge that shows in percentages, maybe this is not as big a deal. I like to get the direct reading. So we're going to connect this gauge to the engine, and we're going to supply 100 psi of air in. Now, inside of this little manifold, we have a one-way check valve. So what does that mean exactly? Well, that means that when air enters the other side over here, and this side is connected to the engine, this gauge right here will be reading the pressure which is able to be maintained between the right-hand side of the manifold and the cylinder chamber. And whatever amount of pressure is able to be maintained in there will display on this gauge over here. Now, if we have to realize that there's going to be some amount of leaking, because no engine, or most engines, are unable to obtain a perfect seal internally. And the reason for that is because there's some cylinder wall clearance, there's some ring gap necessary. Valves in the cylinder head often don't seal perfectly, particularly after the engine has been run a while. If you look back to my previous video, you'll see I diamond lapped my valves, so they do seal pretty good, but nothing is 100%. So when we introduce 100 psi of air into this test gauge, this side of the system over here is connected to the engine through the spark plug hole, and that basically means that this gauge right here is reading the pressure that the engine is able to maintain inside the cylinder. Now, we want this to be a dynamic situation, because as the air leaks down, we would just see this needle leak down too. But if we're constantly supplying 100 psi of air into the system, then if there's no leaks, this side over here should maintain at 100 psi. But if it doesn't, let's say the best it can do is maintain 80%, then what that tells us is that somewhere over here in the engine, whether it be the rings or the valves or whatever it is, we have in the entire system, we have a 20% leak overall. Now, as long as you are supplying 100 psi of air in, this gauge, the secondary gauge, will read whatever the pressure the engine is able to maintain on this side. Now, as I say, in a minute we'll get to testing my actual motor so we can see some of this in real time, but there's a couple of things to be aware of, and they can have a dramatic impact on the results that we see on our leak down tester. First and foremost is engine temp. If you do a leak down test on a cold engine, you may see 20% leak down. If you start your engine and run it and circulate the oil, and remember the oil gets on the cylinder walls and helps the rings to seal, and the engine temperature causes expansion in our aluminum pistons and so forth, and we're able to obtain a tighter seal. When the engine is hot, and this is cold over here, when the engine is hot, this reading may drop clear down to 5%, only a 5% leak down. So we're getting a 95% seal, effective sealing when the engine is hot. So that's something to really be aware of, because if you do a leak down test on your engine, you may see a 20% leak, but if you warm the engine up a little bit, it gets some oil flow, and you might only see a 5% leak. Generally speaking, on an engine that's up or near operating temperature, generally speaking, you want to see not much more than a 10% leak in the engine. Now, technically, if the engine is worn or it's old, and you can start to get up in the 15 to 20% leak down range, and that's still okay. You got a C+ on your test. We'd like to see 10% or less. As you will see in the video of me doing it in my truck, because I diamond lapped the valves, and I have a block that some of you may remember, I hand scraped it flat. I have pretty good sealing across my cylinders. Nevertheless, on my particular motor in cylinder number 2, I have a little bit of taper. I have not the most ideal situation because there's a little scoring in the cylinder, and you may see that cause a little bit of a lower reading. But we'll get on with that in a minute here. The basic thing to understand is that temperature can radically affect your reading, and even if you have a reading down around 20%, that's not necessarily cause for alarm, particularly if you have compression check readings that are up around 170 on a 22 RE, for example. So these are some things to know going into doing a leak down test. Also, some other stuff to know is that when you're applying 100 psi of pressure into the cylinder here during the leak down test, and you multiply that 100 psi across whatever the surface area of your piston that's 3 inches across or whatever, you're generating some fairly significant downward force. So you must block the wheels using wheel chocks, or you must have some safety measure employed so that when you apply air into the chamber, you don't accidentally thrust the piston from top dead center down to bottom dead center and jolt the car forward. So that's something to be aware of. Additionally, you need to lock the rotation of the engine, typically using the transmission in conjunction with the wheel chocks, and this allows you to set the engine at top dead center and then run your compression check. Now, something else to be aware of is that in some instances you may want to, particularly if you have very readings that are a little out of whack on some cylinders, you may want to rotate the engine over and draw the piston down slightly in the chamber, in the cylinder rather, while still keeping the valves closed, in an effort to get a reading further down in the cylinders where there may be less wear, and that has to do with the thrust angle of the crankshaft and the connecting rod of the piston and wearing inside the motor and stuff. So in some cases you can even, depending on your camshaft timing, of course, you can even get the piston very far down in the bore and get a slightly different reading. So those are some things to be aware of. All right, let's get on with the video here. And I know this is going to be kind of a lengthy video, but let's get on with the video and let me kind of show you the highlights of running the actual compression check on my 22RE. All right, this shows my leak down tester, which I'll be utilizing. So you can see there's several pieces that I put together for my particular gauge. This is the piece here with the 14 millimeter threads that goes into the spark plug hole. And it can either be connected directly to the exit of the leak down tester, or I can utilize an extension here to help things out. Now, the leak down tester that I'm using is an older version by Total Seal piston rings, which also happens to be the piston rings I like to use. This gauge, this particular version of their gauge is much older than the ones they sell now, and it utilizes a couple of German-made gauges that are direct read. So in other words, both gauges read the actual PSI we're seeing. But the basic idea is we run air from our air compressor in here, and then we dial it up to whatever our test pressure is. I usually like to use either 80 or 100 PSI. And then on this side, since it's connected to the cylinder, it will be giving us a back pressure reading on this gauge. And the differential between these two readings will allow us to calculate our leak down percentage, which will give us some insight into how well the rings and the valves and the head gasket, etc., are sealing. So we'll get to that here in a second and see how the 22RE is faring. All right, so as you can see here, we've used our 3/16 spark plug socket to remove the spark plugs, and I have them here so we can inspect them. And as you'll note, I have the ground straps modified, as I've covered in previous videos, and I'll put a link to the video where I discuss that a little further. All right, let's get on with the leak down test. As mentioned, we'll need to roll the motor over to top dead center on cylinder number 1, and then we will attach the gauge and put some air into the chamber and see how much of a leak there is. All right, so you can see I have the hose threaded into spark plug cylinder number 1, and we're going to take a 19 millimeter wrench here, and we're going to roll the motor over using the bolt on that lower front pulley damper on the nose of the crankshaft until we get the motor to top dead center. And then we will put a little air into the chamber to confirm it's top dead center on the compression stroke, and then we'll be able to move forward with our testing. All right, so put a wrench on the thing, and as you're looking at the 22RE from the front, it rotates, of course, clockwise. So make sure we got the right direction here. And I have a timing mark in yellow that you'll see coming up here in a moment. There we go. So, and you can see there, get some light on things. We want to roll that up until it's exactly at 0 with the timing mark. And now if we do a leak down test, we can see the results here. So we'll bring the supply pressure up to 100 psi. And so now what we can do is we can dial up the pressure going into the system. And just to make our mathematics a little easier, try to get things situated here. Just to make our mathematics a little easier on us, we'll dial up the source air to as close as we can to 100 psi. All right. And so then what we want to do is we want to look over at this gauge and see how much pressure is being preserved in cylinder number 1. And by looking at the gauge, we can see it appears to be 92.5, 93%. And of course, that's pretty darn good. What this is telling us is that we have approximately a 7% leak in cylinder number 1. And of course, you're going to have some amount of leak because you don't have perfect sealing on your valves, particularly as they age, and you don't have perfect sealing on your piston rings because you have piston ring gaps and so forth. Now, what we want to not see is something substantial like a 30 or 40 or 50% leak, because that would be indicative of, say, a broken ringland or a burnt valve or something of that nature. And not only would you see it on the gauges, but you would hear the air rushing out of the chamber. So for cylinder number 1, we're good. Let's move on, and I'll quickly show you cylinders 2, 3, and 4. All right, so as you can see, I've moved the hose from cylinder number 1 to cylinder number 3. And the reason for that is we know the firing order on the 22RE is 1342, and that's generally what it is on most 4 cylinders actually. So that means after you have cylinder number 1 at its top dead center on the compression stroke, if we rotate the engine over 180 degrees, that will bring piston number 1 down to the bottom of its stroke on the crank and bring piston number 3, the next one in the firing order, to top dead center on its compression stroke, since it's the next one in sequence to fire. So what that means in terms of the front crank is you're going to need to rotate the front pulley 180 degrees. And you can see down there I've temporarily put a silver Sharpie mark exactly opposite of the actual yellow timing mark, to give us an indication of when we're at top dead center. I'll show from underneath the truck here in a moment. So here we can see, when looking underneath the vehicle, that the actual timing mark is pointing directly down at the ground. That tells us that we're 180 degrees from where we were with top dead center on piston number 1. Alright, so now we're reconnected with our air supply. We're on cylinder number 3, top dead center on its compression stroke, and do not forget to put the engine back in gear with the transmission. Otherwise, you can create a situation where the motor will spin over with compressed air. If you have an automatic, you may need to, due to the torque converter, you may need to physically block the rotation of the motor, although the hydraulic forces inside the transmission should be enough, and or the parking pole in park should be also enough. All right, so let's Let's put some air into the system here, see what we get. We'll dial things up to 100 psi. All right, so that's 100 psi. And over here on cylinder number 3, we're seeing, looks like about just a little over 93, which is good. So we're seeing about a little over a 6% leak down on cylinder number 3. So that's more than acceptable. All right, let's move on. And again, we'll need to rotate the motor over. Drop the pressure here. We'll need to rotate the motor over according to its firing order. So 1342. So the next one we want to do is cylinder number 4, and then we'll rotate the motor 180 degrees, and the original factory timing mark will be back at top dead center, and then we'll be able to do our test on cylinder number 4 next here. Alright, so as you can see, we're now connected to cylinder number 4, and as mentioned, I've rotated the motor back to top dead center according to its timing mark. So from cylinder number 1, we've gone 360 degrees. And now we can put some air into the system. And of course, don't forget to put the car in gear or park. All right, so we've got 100 psi coming in from our air compressor here, and we're now monitoring or reading the leak down. And again, what this gauge is telling us is when we're pumping 100 psi of air into cylinder number 4, in this case, this is the pressure that we're seeing. So because this hose is connected directly into the spark plug hole over there, this gauge is reading the pressure present in the chamber itself. And of course our rings and our valves are doing their utmost to keep that pressure in as the piston comes up. So what are we getting here? About, it looks like approximately just shy of 90, just shy of 94 psi. So then just shy of 6% leak down on cylinder number 4, which again is very good, very acceptable leak down readings. Particularly, I should know, because I run my ring gaps. If you see my previous videos, I like to run my ring gaps a little on the wider than normal side. And that's because, you know, if the motor runs hot, climbing a grade, or if I'm towing, the coyotes are at it. So if I'm towing something, or I have the bed fully loaded with, you know, 800 or 1,000 pounds, and I'm climbing and I'm climbing the a big grade in high heat, sometimes, you know, the engine oil might exceed 215, 220 degrees briefly, and so I would rather give up 1 or 2% on my sealing and have a slightly wider ring gap as insurance against butting the rings when the motor is running, you know, red hot. You'll have to excuse the local coyotes. I think I'm clear up around, on some of the rings there, I might be clear up around 28 or 30 thousandths, which is going to be more than what like Total Seal recommends. But I'm also running hypereutectic pistons and ceramic coating in the cylinders and so forth. So, you kind of have to, it's kind of a judgment call. And I usually err on the side of slightly wider ring gaps than slightly tighter ring gaps, because that little itty bitty 0.005 of an inch is not going to, get us from like a 6% leak down to 100, to 0 leak down. And so in my mind, it's not worth the risk of butting your rings and having a catastrophic engine failure over maybe an extra % on your leak down. So, all right, let's see, 1342. So looks like cylinder number 2 is up. Let's knock that off the list, and then we can wrap this video up. All right, so as you can see here, we're hooked up on cylinder number 2 to do a compression check. And as you may have noticed, I have my spark plug wires back on. The reason for that, I had to drive the truck and get some more heat into the engine, because while doing the test and making the videos, the temperature dropped to the point where I wasn't getting as accurate a reading. But now that we're hooked up again on cylinder number 2 here, let's go ahead, and I have the motor in gear with the transmission, and I have the engine blocked, and I believe I have cylinder number 2 at top dead center on its compression stroke. So let's bring up the air into the system here. And for anyone who has been a subscriber of my channel for a while knows, on cylinder number 2, I have some scoring on the cylinder wall, and that particular cylinder also has the most taper to it. So I suspect the reading is not going to be quite as good as on the other cylinders. Okay, and so yeah, we see here at 100 psi input pressure, we're getting a reading of about 85, which is 15%. On my particular motor here, I know from experience in doing these kinds of tests that if I put cylinder number 2 a little further down in its bore, the numbers will jump up to 90 or even 95%, for example, at the bottom of its bore. In cylinder number 2 specifically, I have a little gouge on the wall, and on that particular cylinder, I also have, there's a little taper to it, and the cylinder wall clearances are not quite as tight as the rest of the motor. So 85, which is a leak down of 15, at top dead center is perfectly understandable for that particular cylinder. And as I say, if you're able to accurately move the piston down and get it kind of further down into the undamaged tighter part of cylinder 2, then I've seen readings as high as 90 and 95%. Also, the temperature of the motor, as I may have mentioned in other parts of the video, can have a significant impact on your readings. So for example, if you see cylinders number 1, 3, and 4, earlier in the video we saw 95%, so only a 5% leak down. If I come out and repeat this leak down test when the motor has been sitting overnight, all those numbers will go clear down to 80%, which is a 20% leak down. So that kind of is a good reminder that temperature is a huge factor in any leak down test. So that's something to keep in mind. If you do a leak down test on your pickup and you see 80% across the board and you haven't driven the truck recently, that's no reason to be alarmed. That could be totally fine. And it is good, if you are going to perform a leak down test, to do a leak down test when the motor is cold, as well as when it's very close to operating temperature. I'd say, drive the truck, bring it up to temperature, wait 30 minutes or 40 minutes, and then do the test. And that way you can kind of get a comparison of the numbers. So, All right, well, I hope this video has been interesting to those who are curious about not only how to do a leak down test, but how the leak down tester itself works, and also what kind of results can you expect to see on a 22RE, which has been, not blueprinted but just recently rebuilt as best as you can do without, boring out the block. And as I may have mentioned in some of my videos, the reason I didn't pull the block and bore it is because in the future I'm building a 3RZFE turbo engine for this truck. So this particular 22RE just needs to be reliable. It doesn't need to be perfect. It just needs to get me down the highway for the next few years, and then I will have another motor that I'm working on. So that's kind of the rationale behind why having cylinder number 2 with a slight gouge, which incidentally is above the sealing ring, the second sealing ring on the piston. I decided didn't warrant boring the block over and all that kind of stuff. So anyways, hope you've enjoyed the video, and if you're not already a subscriber to the channel, consider that perhaps. As always, if you have any questions or comments, feel free to use the section below, and thank you very much for watching.